let's take two vectors. Let's assume you are actually in a boat. I was about to put you on a plane. We'll put you on a boat today. And the boat is pointing in that direction. I don't know, we'll pick some speed for a boat. So the boat was going in that direction at a speed of 30 miles per hour. We use miles per hour. An angle you were hitting looks like more than 45. It looks like about 50 degrees. So you're trying to go from this end of the lake to that end. Your friend's house is right there. So you point the boat in that direction and you start to go. The problem with that, the water is moving. It's not a lake, so it's a river. The water is moving and the current is actually going in this direction. We'll go the current in this direction. At an angle of 20 degrees in this direction, and it's a good current. We'll say a speed of 10 miles per hour. What do you think is going to happen to you? If you point the boat in that direction and you start to go, are you going to go to that spot? No. Absolutely not. And is your speed going to be 30 miles per hour? Even if it says on the boat 30 miles per hour, are you really going 30 miles per hour? Sometimes you're going faster, sometimes you're going slower. That's why when you fly from here to Orlando, Florida, on the way up it might take 2.5 hours. On the way back it takes 2 hours and 15 minutes. Where is the difference 15 minutes? Wind, yeah. Tailwind, headwind. So let's see what's going to happen. We'll do this graphically first. So we'll take a clean sheet of paper, and I'll come back and do this mathematically. So I'll leave this page aside. But let's do this graphically and see what will happen. So let's draw an x and y axes. So first thing first, we're going to be, the board is going at a 50-degree heading. So let's do a 50-degree heading. Help if I turn it normally. Here we go. $50. So the boat was going this direction. At what? What speed? 30 miles per hour. So I got to use a scale. I want to make sure you can see it, so maybe I'll make my scale. Here's my scale. I'm going to use 1 centimeter to equal 3 miles per hour. Otherwise, it's going to be too long. So the boat is going at 30 miles per hour. I have it 30 miles, right? So let's do this, 30 miles per hour. That means on my scale will be how many centimeters? How about 10? Right? The other 8. So this is the 30 miles per hour. I'm right here. That's the boat. Now let's look at the current or the wind, whatever you want to use. Instead of 10, let's use 9, just because it's divisible by 3. Let's change that to 9, because you can divide that by 3. You know, I have to use the same scale for both of them. I can't use 2 different scales. So now what I'm going to do is put another set of axes here. I use dotted line because I don't want to make it too messy. So I'm putting another set of axes right there where we stopped. And now we said what? That, is this upside down? Here we go, good. The boat actually was going in how much heading here in this direction? 20 degree in this direction, which means in relation to this side, how many is that? Is that 70 degrees? If you measure it from there, so let me go 70 from there. So in that direction, it's 20 degrees with this, 70 degrees with that one. And the length of this has to be 3 centimeters. My scale is 1 centimeter is 3 miles per hour. And that's it. So now I need to know how fast I'm going and what direction I'm heading. So this is my result. And notice I'm measuring the length of that result. It looks just a hair less than 9. Is yours a hair less than 9? What is that number? Is that a 9? Is it an 8.8, 8.9? You know? So that's my result actually. So this is the wind here, I mean the current. This is the velocity of the current. Water, which is 9 miles per hour. So actually now the boat is going to have a speed. So this is the speed of the boat now is equal to 9 times 3. The scale is 3 miles per hour for every centimeter. I got 9 centimeters. So actually the speed of the boat is going to be 27 miles per hour, not 30. Even the speedometer says 30. The boat is only going 27 miles per hour. So if somebody on the side of the road watching the boat go by, it sees the boat going that direction at a speed of 27 miles per hour. And what heading the boat is going to be going? It's not going to be at 50 degree heading. It's actually going to be going what's that angle? 30, 34 degree heading. 34, 30, 35, somewhere there. So if you point the boat in that direction, you're going to end up right here. That's where you're going to end up. Then you got to walk all the way back there, or drag the boat back with you there. The problem doing them graphically, I tried really to be careful with it. I tried to measure everything the right way, but again, I noticed just my line right now is not really starting from the origin there. It looks like I'm crooked a little bit there. So even when you're careful enough, it's tough to get the exact answer if you're looking for accuracy. So trig is really a better, or mathematically is a much better way to do it than graphically. So how do we do it mathematically? And there are 3 steps that I use mathematically to find where we're going. 1, step number 1 is write the vectors. That's the first step. When I say write the vectors, what do I mean by that? I wanted to make sure all the angles are measured with respect to the positive x-axis. So if I call this vector A, and I call this vector B, I'll say vector A, how long is vector A? It's 30, and what's the angle? 50 degrees. Vector B is what? How long is it? 9, and what's the angle? What is it?
20.
Try again. Almost. Negative 70. Yes.
I had a question from the last page.
Yep.
For the equation that you wrote for like 25 degrees, where you did vector equals 9 times 3, is
Yep.
that because of the scaling?
Scale, correct.
So if I did every centimeter is 6 miles per hour, it'd be
Yep.
like 9 times 6.
Correct.
Okay.
Yep. Whatever your scale is. Yep. So that's how you write the vectors. You always want to use this as your reference. And if you're below this line, that's a negative. If you're above that, that's positive. Step number 2. You need to find the x and y component of each vector. That's what I need to find. The x and y component for each vector. So vector A will have an x component of what? 30 cosine of 50. That's in the x direction. And we'll have a y component of what? 30 sine of 50. So 30 cosine of 50, 19.3 in the x direction, 30 sine of 50, 23.0 in the y direction. That's vector A. Vector B is going to have an x component of what? 9 cosine of what? Negative 70. That's in the x direction. The x is always cosine, the y is always sine. So 9 cosine negative 70, 3.08. This will be a minus number. 9 sine of negative 70, negative 8.46 in the y direction. Step number 2 is done. So this is the x component of the first vector. This is A, the x and y component. And this is the x and y component for the second vector. Step number 3, add the x and y components of all the vectors. Now when I say add them, you can't add x to y and y to x. It has to be x to x and y to y. I call that the result in the x direction, the equivalent. If you were to find one force to replace them, that's the force I'm looking for. The result in the x direction is going to be what? 19.3 plus the 3.8. And that's 22.38 in the x direction. plus, what's 23 minus 8.46? Plus 14.54 in the y direction. Bless you. So notice I know the x and y component. I'll go to the early lecture today. If you know the x and y component, can you find r and theta now? Because you're trying to find one force, one vector. So now I'm going to go back to that, and that's the last step. Here we go. Let's get the result. What is the one force? What's the value of that vector? R equals the square root of the x value. Oh, I don't know why I call this x value. That's the result, x and y. The result in the x direction squared and the result in the y direction squared. This is the x direction, that's the y direction. So I'll put underline. So this value here, this is the result, but this is the result in the x direction. And this is the result in the y direction. So that's going to be the square root of 22.38. Don't put the x there. That's just the direction of it. Plus 14.54 squared. Let's see if my answer is going to be close to what we said the answer was. I said 27 on mine. Let's see if it's 27. 22.38 squared plus 14.54 squared. Take the square root of that number. Ready? You'll be surprised. 712.3, and the answer is 26.7. Remember I said, is that 9? Is it 8.9, 8.8? I was just a hair off. I figured graphically, I said the answer is what? Here's it, 27. And I even questioned the length of that. I said, I don't think it's 9. That tells me it's a hair less than 9. Can I get theta? It is the inverse tangent of the y over x. So the inverse tangent. And what's the y value here equal to? 14.54. What's the x value? 22.38. Do we add 180 here?
No.
Why not?
It's in the
First quadrant, right? We're in the first quadrant. X is positive. Y is positive. You're in the first quadrant. The only time, if you want a shortcut, the only time you add 180, when x is negative. Doesn't matter what y is. When x is negative, you're either going to be second or what? Third quadrant. So let's see what the angle there. Was it close to what we thought it's going to be? Was it around 34, 35 degrees? $33 degrees. 33.0. That's really a better way of doing it. The question is, how am I going to remember all these steps? Lots of them. So I decided when I started doing these, I'm going to do them a little bit differently. I'm going to make a picture for you so you remember what's missing from it. It reminds you of all the pieces that you need to do. So I'm going to do not the same example. I'll do a different one. I get bored after one example. I got to change it. So let's take another example. We have a cruise ship. Here comes the cruise ship. Big ship here. is trying to navigate through a tight corner. Well, it's tough. So what do? They bring in the tugboats to pull on it, push on it, to make sure nothing moves in either direction. So here we go. We want to move in that direction, but let's see what will happen. So we have one tugboat is pulling in this direction. Those little boats have a lot of power on them. We'll call that tugboat A. And it was pulling at a force of 5,400 Newton. You don't have to know what the units are. We'll say this angle is 12 degrees. I got a smaller one pulling in this direction. Give them different angles. This is tugboat B. And tugboat B was pulling at a value of 3,600, the smaller one. And this angle is, what do you want that angle to be? From the y-axis down to here.
160.
No, from here to there, can't be. Has to be under 90.
35.
35? Okay.
I meant from the other one.
Okay. And the third one is pulling back. So assuming the actual ship, the engine is not running. So there's a one pulling straight out of a value of, we'll call it C here. That's 4,000. And send straight down, back. That's a 90 degree, or negative 90. So there's the cruise ship, where you see in these three tugboats pulling on it. So now if I clean that, I can take the cruise ship out, just throw the three lines, and to make it look nice, I go, this is one, this is a second one here, and there's a third one down there. Just to clean a little bit there. This is A, and the value of that is 5,400, and I'm giving you this angle to be 12. This is B, the value of that 3,600, and this angle is what, 35, we said? And this is C here, and the value of that is 4,000. And we know what that angle is, right? So to do the problem, here we go. I'm going to just get rid of some of the stuff here. I'm going to break this paper into actually 3 columns. Leave some space on the bottom. Three columns. The first column, I'll put the second column for the second one. The next one, and the third one. That's it. The first column is going to have the name of the vector in it. The second column is going to have the x component. And in case you forgot, how do you find the x component? X equals what? R times what? Cosine theta. And the third column is going to have the y component. And how do you find the y component? R sine theta. Yep. You got to fill the whole box. That just to remind you, got to do all these pieces. So if you put these labels up there, I got to list the vectors. My vector A, which is how big? 5,400. What's the angle?
12.
Try again. What is it? 78, yes. Why? You always want your angle measured from here, from that line. Vector B, while we add it. What is that equal to? 3600, what's the angle?
Negative 55.
What is it?
Negative 55.
Negative 55? Nah, not really. You gotta measure it from here. We know from here to there is what?
Oh.
90. 90 plus 35 is what? 125. And vector C, which is 4,000, and what's the angle? Negative 90, or plus 270, either way. You can measure it this way, that's plus 270. You can measure it that way, it's negative 90. Again, you always want to measure the angle with respect to this line. That's your reference line. Now, we're not done with the table. There's a lot of empty boxes here, right? So I need to find the x component for each one. This will be 5400 cosine 78. This will be 5400 sine 78. We'll round them to a whole number. We're not going to use decimal places here. 1123. Five two eight two. $3,600 cosine 125. 3,600 sine 125. Negative 2065. $3,600, the sine of 125. 2949. The x component, 4,000 cosine negative 90. That's a 0. 4,000 sine of negative 90. That's a negative 4,000. And now you're going to add them, the sum. That's your R, the result. This is the x component of it. This is the one in the x direction. You add the three numbers. So let's add them. 1, 1, 2, 3 minus 2065 plus 0, negative 942. And the value in the y direction, 5282 plus 2949 minus the 4,000, 4231. So now we're almost done. Let's see, how do you find R? I'm trying to find R and theta. That's the square root of what? R sub x squared plus R sub y squared. That's the square root of negative 942 squared plus 4231 squared. I got 4335. And what about theta? Isn't that the inverse tangent of the y value over the x value? Y is what? 4231 over the x value negative 942. Are we in second or third quadrant? Is x negative?
Yes.
If x is negative, what do we do? Add 180 degrees to that answer. So we're going to go at 102.6? Is that what you guys got?
No.
Check your region.
Maybe I did something.
4231 divided by negative 42 inverse tangent.
You didn't finish the conjugation.
That doesn't matter. I got
103.
I got 257. Oh, maybe I did something.
Can't be. You're in the second quadrant.
Oh. You know what I did wrong? I put the second one negative, or the first one negative.
Oh.
Negative 4321. That's fine.
So 103 degrees heading.
Yep.
So you're almost going straight. Straight is 90 degrees. They were just go in that direction. You know, with a tugboat. Instead of straight, they just pull in that direction. You know, because 103 degrees will be like, that's a 90 degree right here. So 103, 10 degrees more than that. So the boat was really moving that direction. They got the cruise ship to go in that direction. You know, that's the direction they got it to go. But anytime this value is negative, again, you need to remember to add 180 degrees to theta. Why? Because of that value. When that number is negative, you have to add 180 degrees to theta. Because that means you're in the second or third quadrant. Doesn't matter what that number is. I find the table a bit easier because it just lets you know you're missing stuff. It's not complete. It's not complete. You need the vectors, the x and y components, and add them. And at the end, you got to add the last step. If I was to subtract angles, we do the same thing. So I'll stop the video and I'll ask you some questions to practice here.